It's great to be here with all these people who care about privacy. And institutions want privacy as well. And in fact, they want quite a bit of privacy. And specifically, they want two kinds of privacy. Basically, every business agreement can be boiled down to a very simple explanation. I've got money, you've got stuff, and I would like to exchange my money for your stuff under the terms of that agreement. So the money and the stuff can be represented as digital tokens, and the terms of an agreement can be represented as a smart contract. So at least in theory, it sounds really good that we could have like full business contracts under privacy on a blockchain. In practice, however, this is really, really difficult. And so over the last like 8 or 9 years at EY, we have been spending a lot of time trying to figure out how to actually make this work, how to make it practical. And we've ended up building and making available a couple of tools to support privacy for business users. And then we are actually applying them in business applications. And what I'm going to do today is really take you through what we built and how we actually try to apply it. So I'll start with the first tool that we built, which is called Nightfall. Nightfall is an Ethereum Layer 2 network. It is a ZK optimistic rollup that allows you to move those money and stuff tokens around under privacy. So basically, and I've got a little picture, you can basically take a stuff token like a truck or a money token like a stable coin, and fungible and non-fungible tokens basically, and you can put them into this kind of black dark pool where nobody can see what's going on, and you can transact with other people. You can move tokens back and forwards, you can pay people, receive payments, etc. Now, we have designed this in such a way as to support like lots of different business models and to support auditable, provable histories of transactions. We have, however, gone to some lengths to make it unattractive for bad actors. So you cannot use Nightfall without identifying yourself. So you have to have what's called an enterprise X.509 identity certificate in order to use that. Those are available from pretty much any of the big SSL certificate providers. They require you to prove your identity with things like tax documentation, and they're actually widely accepted as legal digital signatures. Now, it's kind of unique where we have positioned Nightfall. So if you think about a 2x2, and I am a consultant, I'm a recovering consultant, so I have to make a 2x2. But if you think about a 2x2 and you think about the axis between identified and anonymous or public versus private, we are in kind of a unique position here. We're focused on what's called the identified and private space. You have to identify yourself, right? And actually, you have to be an enterprise to use this. Nightfall does not work for individual users. But the content of your transactional data is private. And that's very different from, say, the public Ethereum ecosystem. Like, you can go to prbrody.eth and have a look at what NFTs I own, which is not a lot. And you can also have kind of public and anonymous or pseudonymous transactions like on just a general Ethereum address. And you can also have private and anonymous transactions, which are what you get with things like Tornado Cash and other types of services. Our business and our focus, we are not in this like private anonymous space. We're in this private and identified space because enterprises are not here to have complete and total secrecy or anonymity. What they're here to have is privacy from their competition. That's what really matters. I don't want to tell my competitors what I'm buying, from whom, and how much I'm paying, right? So that's part one. And by the way, the speaker who was here before me, he did a great job explaining just how fabulously difficult it is. But let me give you a kind of a real-world illustration. We started this journey in 2016. We were like, you know what? We need privacy to make public blockchains usable. And we hired an engineering team, and by 2017, we were actually doing like math. We had to hire a lot of mathematicians, which is a bit of a new thing for EY. And in 2018, we showed a prototype of Nightfall. And to the point about these computations being difficult and expensive, it cost an average of $100 in compute power to complete a single transaction. We're like, this is not going to scale. And we have made steady progress. Like from prototype to version 1.0, we got transaction costs from $100 down to $5. In version 2, we got it down to $2.50. And then we really sort of went on the grind. And by last year, version 3, we were down to about a penny. So we have made some pretty big improvements. We started with $100 a transaction. We're now to about a penny. We need to go, in my opinion, another 1 or 2 orders of magnitude lower. And the reason for that is that enterprise users, so if you're buying stocks, if you're buying a house or something, a penny, 50 cents, $2.50, it's irrelevant, right, in the cost of a substantial financial transaction. But if you're an enterprise, and we have some enterprise clients, they're like, hey, we'd like to move, 2 million NFTs per day. 2 million a day, right? Now we're talking some really serious gas fees. And 2 million a day, you think, like, what are you going to move 2 million a day? The answer is you can move about 2 million a day of a single product line of serialized medicine. Right? If you want to keep track of all of those items, and by the way, each one of them is a non-fungible token. Every package of medicine, every iPhone, every computer, every car, it's an NFT, right? And so if you want to move a couple of million of those a day, right, through the various stages of the supply chain, your costs need to be really low. Earlier this year, we announced a new version of Nightfall. It's called Nightfall 4. It's a ZK rollup, which means one set of zero-knowledge snarks for privacy and another for succinctness and instant finality. And that means you can actually do these transactions very cheaply, very efficiently, and you can also make sure that they are finalized very, very quickly. So the second thing we did was work on this thing of the business agreement, right? If I have to publish my business agreement with you in the clear, then I've kind of missed the point of half of the work that we are doing together, because it's one thing to expose how much I'm actually doing, but it's almost as good to know that my agreement says I'm going to buy 1 million widgets from you over the course of the next year, and you're going to charge me $4 each. That's, people say, like, how much are you going to buy? Well, probably somewhere around 1 million widgets, right? We've kind of exposed the whole thing. So we then had a very similar experience to our prior speaker. He said, coding these things is hard, very hard. We tried to train our developers, and it was a colossal failure. I mean, just like an epic face plant, right? They're just like, we are not learning this, we hate it, we are not doing it. So we then built an application called Starlight. And Starlight is kind of nifty. What it lets you do is take a traditional Ethereum smart contract written in a somewhat modern programming language called Solidity, and just hit the transpile button, and it turns it into a zero-knowledge circuit that you can run on-chain under privacy. Now, I'm exaggerating about how easy it is, because it's not. But it's relatively vastly easier, to the point where our developers stopped kicking and screaming and said, we might be able to make this work. And Starlight basically allows anybody to build a privacy-enabled application. In fact, the Central Bank of Brazil and 80 banks in Brazil are testing out Starlight today as part of Brazil's central bank digital currency program, because they have important banking secrecy regulations. They require all banks to basically keep their transactions secret. What can we do if we have money and stuff and the business agreements together? Well, basically, we can completely transform how businesses interact with each other, right? If you think about a very traditional supply chain, buy, make, move, store, and sell, right? Those are the traditional things. I got hammered into me in the first supply chain software company I worked for. Buy, make, move, store, and sell. Super easy, can't forget it. Well, today, almost all of those things are basically different silos, right? When you move stuff from company A to company B, they don't really move your data, they just like duplicate it, and they usually make a bunch of mistakes. But it turns out that if we can create digital tokens and smart contracts, we can move all this stuff really smoothly and succinctly across these networks in a way that's very transformational. So if you imagine that if you are making something, and the raw materials are all represented by tokens, right? You can just imagine supply chains, the world of stuff that we buy and use. It's just this like ocean of tokens moving from left to right across the screen. And what's really cool is along the way, we can have perfect traceability. You can run a vastly more efficient supply chain. And the reason you can do that is because blockchains do something really cool. They let you apply the technical and operational discipline that a bank has to the smallest payment to anything, right? Today, if you run like an ERP system, I can make inventory appear pretty much anywhere. But on a blockchain, if I want my widgets to come out of the manufacturing facility and into your warehouse, they have to actually come out. We have a disciplined, process to make sure that there's no double counting of assets, there's no duplication. And that turns out to be incredibly valuable in terms of running an efficient supply chain. We estimate, just to give you a little sense, that you can run a comparable supply chain with 10 to 15% less inventory just by being more accurate, just by keeping track of what you've got, right? And when we add to that the business rules, right, that govern, hey, I move this stuff, you're going to pay me, and you can start to build together this kind of complete picture of a supply chain with stuff moving from left to right, money moving from right to left, and everything running automatically. And by the way, the running automatically thing, also incredibly valuable. Large companies, how many of you work for large organizations? Yeah, large organizations, fantastic at negotiating. They have specialized procurement departments, great lawyers. 5 minutes after they have signed it, they're like, wait, when do we get our discount? They've completely forgotten. Right? Smart business agreements, smart contracts are transformational because it make it possible for the buyer and the seller to just put their deal truly on autopilot. And you actually get the deal that you negotiated, the price that you agreed, the discount, the rebate, whatever it is. Now, the prior speaker said we're years away from doing this. I am a tiny bit optimistic, more optimistic, only because we are actually doing little bits and pieces of this today. So for example, at EY, we just finished our first pilot project with a real electronics company tracking their product from raw materials through manufacturing, logistics, and out to the data center. So they make computers, and they're basically tracking it from literally the mines, mining kind of the key raw materials, to the data center. We are tracking all of that using tokens on the blockchain under zero knowledge. Now, it's just a proof of concept, and it's quite difficult. It's difficult because things that are super easy without privacy, like traceability, where did it come from, how many do we have, turn out to be incredibly difficult. We have built a really, really good privacy thing, and as the prior speaker mentioned, like when you have privacy, nobody knows where stuff is except for the person who has it. But that's not how companies like to work. The manufacturer of a computer chip wants to know, where did my chips go? I have a defect. I would like to be able to recall all of those items very efficiently. So there's a huge amount of work yet to be done in terms of figuring out how to manage some of the things that enterprises want in very complex supply chains. But we're getting there. It's real. Another one that's real and is really exciting, I guess I talked about this. Another one that's real and is really exciting is we have our first smart contract application running in the market today that uses zero-knowledge circuits, these compiled zero-knowledge applications, to actually run a business contract. And in this case, what we've done is we built a renewable energy application. So people buy renewable energy. Companies enter into long-term contracts all the time to buy renewable energy. It's pretty typical. But these contracts are actually a little bit messy because I'll agree to buy a gigawatt of electricity over the next few years at a certain volume per month at a certain rate. But in reality, what happens is you buy electricity on the open market based on the current market price, and then you have to settle up with each other at the end of every month. Did I pay more? Did I pay less? There's this like back office complicated settlement process. Our smart contract that we built basically keeps track of all of those pieces of data and then calculates the correct settle-up payments at the end of each month automatically, right? And this is a great example of the kinds of complex business logic that you can implement on a public blockchain with privacy. So the participants, nobody knows who's buying what from whom. They do not know how much people are paying, right? And then separately, as the next phase, we will incorporate the payment process into the calculation as well. So to me, this is really exciting. It's a real project. Now, we can't just go out and add yet any old contract type. Each one of these contract types, like renewable energy or business procurement or something else, has to be developed, engineered, and tested one at a time at the moment. I do hope 2, 3, 4, 5 years from now, we will get to the point where like any user can just assemble a very sophisticated privacy-enabled smart contract, with a drag and drop or through like an AI interface. We're not there yet. But what we are is we are building real applications that are able to do this and kind of operate effectively on public blockchains under privacy. Now, we do have some interesting quantified data about how valuable this kind of automation is. And spoiler alert, very, very valuable. So several years ago, we were asked by Microsoft to come in and build a new procurement system for the Xbox video game network. Microsoft buys billions and billions and billions of dollars of video games every year from thousands and thousands of different companies. Some of them are very big and they have incredible negotiating skill, and some of them are very tiny. And Microsoft was struggling with the enormous volume of contracts and the volume of transactions, and they asked us to come up with a better way to do this. And what we did was we developed a set of smart contracts. We took each of these thousands of procurement agreements and turned it into a smart contract. Now, this was before we knew how to do this with good scalable privacy technology. So we did it without privacy on a private blockchain. So an imperfect test. But we have some useful data. We took the amount of time it takes for Microsoft to calculate their royalty payments from 45 days to about 3 minutes. Now, everybody always asks me, like, well, did the suppliers get paid in 3 minutes? Absolutely not. They held on to the money. But the suppliers did know what was coming to them in about 3 minutes. The entire system costs about 40% less to administer, and pretty much everybody using it was much, much happier because they could log in and look at the progress of their contract. They could see, how many items had been sold, what kind of, revenue was coming their way, how the logic of their business contract had been applied. So we know that as this scales up, the return on investment for using privacy on a public blockchain is going to be really enormous. In the end, I would say my own expectation is that blockchains and zero-knowledge technology will eat the entire business-to-business software market, right? At the end of the day, the way businesses interact is they buy stuff from each other. That's what they do, right? And ERP, this enterprise resource planning systems that are used inside of companies, were designed to mesh process, organization, and operations together. But the problem with ERP systems is that no company is an island. Almost all the real problems that exist today in large enterprises, they emerge when large companies try to transact with each other, right? They have different definitions, they have different agreements, they like to send each other spreadsheets, right? With blockchain-based smart contracts, companies can agree with each other on data and process in a single infrastructure. So I think ultimately all B2B agreements will migrate over time into an on-chain environment. And by the way, I would say we directly believe that it will mostly be a public blockchain environment, not a permissioned or private network environment. But that will only happen if the enterprises involved feel confident that their business transactions are private. All right, so I will finish up by offering you all an NFT. According to our legal department, I need to promise you that it is worth absolutely nothing and for entertainment purposes only. But if you would like one, it is there. We jokingly refer to these as proof of Paul, and they are proof that I was here and that you had the misfortune of having to interact with me in person. It's probably not usable for contact tracing purposes. And that is it. I think somebody was going to come up and ask me a few easy questions, some softball questions. Was that you, Paul? So it's going to be two Pauls on stage. So you'll have to, and it's worse than that. It's two Paul Bs. That's right. Because you have a Brody and a Brigner. So I don't know how you're going to tell us apart. But you can say to the guy who has a really nice jacket, that will also work.
All right. Well, I want to dig into something that you mentioned there because it's something that's been on my mind a lot lately. You suggested that we're probably talking about this on a permissionless public network. Let's talk about that for a minute. I think that's a really important topic. And why do you think we're headed in that direction?
So permissionless public networks are essential for kind of growth and innovation. I think one of the lessons that people sort of tend to ignore is that the internet is a permissionless public network, and it really outcompeted. And I feel like I'm very old, so I can say this. I was around for AOL and CompuServe and all of these like private infrastructure. Public networks outcompete them every single time, and I think it would be very surprising if we had a big departure from history and they didn't outcompete all these sort of private network visions that exist today.
That's great. So, so you talked about some of the projects that are on that you're using right now, or using your technology. I think you mentioned that was the Bank of Brazil or the Brazilian government. Are there any others you can mention? Are there any other pilots that have been going through?
So it's a really slow process, and I would love to give you a long list of customers, but I don't have one. We've got the Central Bank of Brazil, which is doing an amazing job. Although I have to tell you a great story. So we were asking them, can you pay a bit more for the work that we are doing? And they're like, oh, it's not in our budget. I'm like, come on. Every client says they cannot afford to pay. But you're the central bank. You're in charge of printing the money. You're really going to ask me to believe that you can't afford to pay a bit more? So, and they held firm. So I know that fiscal discipline is in place in Brazil, but it's a slow process, and we are doing everything we can to make it simpler. But the issue is zero knowledge stuff is hard, it's complicated, and it takes a lot of people have to overcome their skepticism to come and believe in it.
So it sounds like it's a potential technology for a CBDC, right? Central bank digital currency. That's probably why they're doing the test. Yes. What about stablecoins? Is this a technology that you could apply to USDC or some other stablecoin?
Any non-fungible or fungible token can work, for example, in the Nightfall environment. It's designed to support those types of tokens. So absolutely, yes. And I certainly anticipate the US is a very good example. It's extremely unlikely that we'll have a CBDC here. So to the extent that this takes off, it's going to be all using stablecoins for payments.
So I know that in addition to your day job, you are very close to the Ethereum Foundation, right? It's the Enterprise Ethereum Foundation. Is that correct?
I'm the chairman of the Enterprise Ethereum Alliance, which is kind of a somewhat related organization to the Ethereum Foundation.
So are there any activities there that you can tell us about, any other upcoming things that we should know about or tune into?
Yeah, absolutely. So next month in Bangkok, there is DevCon. It's the Ethereum Developer Conference. And I think actually there's a few people here who will be there. The Ethereum Foundation has been mentioned before. It's really pouring a lot of money into Starks, privacy technologies. And so there's a lot of activities going on there. The DevCon is going to be for developers. If you want to talk about businesses and use cases, I'm actually hosting an event called Industry Day, which is the day before DevCon, and it's really to talk about use cases and business applications. And specifically, I've actually assembled a lot of the firms that are working on privacy technology, including the British one, I'm getting their name is leading me at the moment. Aztec, thank you. Aztec, which has some really fantastic math skills. They are coming to that event, Aleph Zero, and I'll be there, and we'll be talking about more on the business applications of privacy. But it's a space, zero knowledge generally has just made 10,000x improvement. So there's a lot of stuff happening. But anyway, eeaday.org if you would like tickets for that. Thank you for giving me the opportunity to plug that.
That's right. Well, thank you for being a part of this event today. I think you've added a really unique dimension to this conversation, showing that this technology is being used today on Ethereum for enterprises. And thanks for your leadership. And I encourage everyone to tune into your work and go to DevCon if you want to take a trip to Bangkok.
Thanks, everybody. Thanks for having me.